creating one super group. Wow. What's your idea?
And then, of course, Spark Plaza, which is this place. So we've got some awesome sponsors. So thank you for helping make this happen. So tonight I'm going to be giving the talk. Shouldn't be super long, but I encourage participation in all of my talks. It's always better to have discussion rather than just somebody talking straight, because you can learn so much more from other people.
Does heckling count?
Does what?
Heckling count?
I would expect heckling, basically. Okay, so my talk title is called Code This, Not That. So it's basically a play on Eat This, Not That, which was a book basically saying, hey, you're eating this thing like a cheeseburger, and we all know it's tasty, and the object is to not be hungry anymore, so you obviously need to eat something, but you should replace it with this other thing, which makes you not hungry, and is also tasty, but is actually better for you. So it's going to be focused on things that you probably already do, or maybe you used to do, that is good, but there's some other things that you may want to consider doing to replace those things that would actually be better. So let's get started. So the first thing, I'm going to split this into two parts, maintainability and performance. So the first half will be just about writing good code that will help you be more correct and precise and make things a little bit more readable. And then the second part is things that you should do instead of other things to make your app more performant. So maintainability. The first thing, how many of you guys know what the difference in double equal and triple equal are? Do you guys all know that? Okay. So this actually, so this actually is surprisingly not very well known. In interviews that I've done, I think I've had 1 out of about 18 people get this right, or even know that triple equals exists sometimes. So here's a few different examples, if you can see them. So I'm doing var x is equal to 2, var y is equal to 1 plus 1, which is of course 2. X double equals y is true. Same thing with triple equals. It's the exact same thing. X equals 20 is false. X triple equals 20 is false. Same thing if you compare it to a string, of course false. So why would you even need a triple equals? So they're pretty similar, but they're not actually the same thing. Most people think that they're the same and they're interchangeable, but really they're not, even though they look the same. So JavaScript has this concept of truthiness. So the actual Wikipedia definition says it's the quality of seeming or being felt to be true, even if not necessarily actually for realsies true. So show you an example. This is what we would think of. This is a truth table for one of the two equal signs. This is what we would expect to be true, right? So true is equal to true, of course. The next one's false is equal to false. 1 in quotes is equal to 1 in quotes, and everything else is, of course, false. So this is the truth table for triple equals. And this is what we would kind of expect things to be like. This is similar to C#, Java, other languages like that. So what if I told you that your double equal truth table actually looks like this? It's crazy. It's all over the map. So things like true is actually equal to 1. So if you compare, is 1 equal to true? Yes, that's true. Also, an array with another bracket inside of it is the same thing as false. It's also the same thing as 0. An array with 1 in it is equal to 1, and it's also equal to true. So there's all kinds of other craziness happening in here. So in general, the takeaway from this is always use triple equal. Okay? So speaking of...
So why does it exist then in JavaScript?
So Yeah.
So why are you just trying to take it away? It's part of the language, and this is a JavaScript meeting.
Yeah, exactly. So for 99% of the things that you want to do, you probably want to use triple equals, because when you're doing a comparison, generally you're like, oh, I want to make sure that this thing is this exact other thing, and not something else like an empty array or something.
Well, what if I don't? What if I just want it to kind of just work?
You can do that. You can do that if you want to.
Yeah, less typing.
It's a free world. Yeah.
Sorry.
It's
You said I could have
less
that.
characters going over the wire, so it's more performance, obviously. So speaking of comparisons, how should you check if a value is undefined, right? So like normally in Java or C#, you say, is this equal to null, right? And so you obviously, in a top language like that, you can't just say like it's something random equal to null, because the compiler will say, well, you've never even declared this variable, right? But in Java, you can use anything, even if you've never declared it before, and it'll say, oh, well, maybe you just mean the global variable, so I just start it up, and it'll set it to undefined. So how should you check to see if something is undefined? Well, a lot of people will actually use this. They're using the triple equal, so that's good, points to them. But there's actually a weird thing in JavaScript where undefined can actually be a variable too. So you can assign a value to undefined. So I could assign undefined false, or a quote in like a string, like this isn't defined or something. Pretty much whatever you want it to. And it changes the behavior of what undefined does. So instead of that, you should actually do this type of thing. So what you actually do is you do type of whatever your variable name is that you want to see if it's undefined. And if it is undefined, it'll actually return a string with undefined in it. So yeah. So that's the reason why you would see that in JavaScript code, and you're like, oh, that's really weird. Why don't you just set equal to undefined? Because I get IntelliSense in Sublime to say undefined. That's why. It's because you can actually change the meaning of undefined, and it gets kind of crazy. Yeah.
What if you created an object and changed its class to be undefined? And what would happen?
Like change its name?
Yeah. Well, I can't. I did the talk on object-oriented JavaScript like a year ago, so I can't remember any of it. But
Yeah.
But it seems like there's a way to specify the class name, the prototype of the.
Yeah.
Because I did not know about the undefined.
Yeah.
I never thought to look
But just curious. I didn't mean to. It's something
Yeah.
we'd have to Google
for
later.
that. I knew
Yeah.
JavaScript the good parts.
Yes. It's a good book. But yeah.
So can you set the undefined variable to anything, or is it a boolean like you can only do a lot?
I think you can set it to anything.
Really?
I'm just surprised you. Yeah, I'm surprised you do that.
Yeah. It's really
Global
weird.
Variable, global object variable.
I think there's actually a hack inside of jQuery where it checks to make sure that somebody didn't redefine undefined
Just
before it starts doing stuff. Yeah.
I mean, you could modify anything in JavaScript if you want. Just change the prototype. You know, that it's based on.
Yeah.
It's a bad idea. But
Yeah. So basically, like what you're saying, like it's probably not going to happen, but it could.
I would want to, because I'm a little out of my depth here. I would want to see exactly what type of does. What the string it returns does it return
Oh, yeah, well, that's
the name of the
type of
function in prototype?
Oh.
Does it return that? What's it doing?
So there are. So if you do type of on different things, if you do type of null, it'll return object. If you do type of not a number, it'll actually return number, which is weird since it's not a number. You would think it was not a number, but it's a number.
So everything
That's
would be
not
an
a number.
object. Any custom object would just return object instead of the prototype or whatever.
I think so. Yeah. Yeah. So types kind of crazy, but in general, if you're doing undefined, make sure you use the type of just to be 100% sure.
in JavaScript, can we open up the classes and change? Is that basically what y'all was talking about by changing the prototype? Like, can you open up the number class and then modify methods that are?
Well,
Yeah.
so if I remember right, there's like 5 basic categories of data types in JavaScript, and like numbers and strings and stuff are not necessarily considered objects.
Right.
But there's this thing called an object. And so I don't know if you could change the prototype of a number. But this is JavaScript, and you can read that not a number is a number, and nothing is an object.
So that
Right.
means
So
you can like
anything
open up
goes,
the
really.
object and then modify whatever node is through if you.
Yeah. I mean, you can define undefined, so that undefined is defined.
What does the
So
what does
The
the
mass
there's
chaos.
that.
so what does the fast facts function do?
Fast facts returns facts.
Okay,
Yeah.
I love JavaScript.
Yeah. So another thing is use the module pattern. So I didn't put what you should use this in place of, but really what you should use this in place of is a lot of times if you're building a web app, you may have a lot of different functions that you want to kind of like break out into your own little library that are similar, and sometimes people will just make create a new file and then just put a ton of functions in there and then just call them, that kind of thing. When you do that, everything is kind of up at the like the root level as far as like namespaces go. So what you want to do is use the module pattern, and that'll kind of isolate all of those inside, so you won't have any like the bleed over from any global variables and that kind of stuff. So it's actually pretty easy to do. You would normally just write your function like this, and instead you add a couple of parentheses. So you add parentheses around the whole thing, and then after you define your function right here, you add 2 more parentheses. And essentially what these do is say, go execute kind of thing. And you can actually, so it isolates you from any kind of global variables, but sometimes you may want to use some of them, like if your library depends on jQuery or Ember or something like that, for example, something specific, you can actually pass those in and say, I don't want to touch anything else, but I actually do need jQuery, so give me that. So you can pass in variables and then give them a name that you want to use inside of your function, inside of your little module. And then the last step is you can actually assign that to a variable itself, and that'll kind of roundabout's way give you a namespace. So I've got this, yeah. So you got your module here, and then inside of it you basically create a new new object. You can have some private variables on it. Here's a private method, and then on the actual object that you're building, you can do a like dot some awesome property, some method that you can call, and then return that object back out, and that'll assign it to this. So then you can use that by just calling whatever this is, just like you would jQuery or something else.
And I guess you would call the private method the same way you call the callback method right down there, the anonymous one, or some method you can call.
Yeah, so actually this won't be available to you.
Oh, well, never
Yeah.
mind. Yep.
Yep, so
So your public, that would have been better. Your public methods would just be methods that you added on that you would just call the same way, just like you did with anonymous one.
yep.
Okay.
Yep. So that's basically how you do it. And so the main thing, if you can just remember, is just add parentheses, and that's really all there is to it. So it's pretty easy. If at first glance you're like, oh man, all this other syntax, I got to remember how to do it. But it's basically just add some parentheses and then build up an object and return it inside of it. So that's a really good way to keep everything nice and tidy. You don't have to worry about smashing up against any other libraries that you may be using. Because especially sometimes people make names like apply or do it or something pretty generic like apply values. Like that's pretty common and probably more likely to smash up against something else. So this at least guarantees that everything's separate. So some documentation. So instead of using just // and then just trying to comment wherever, there's this thing called JSDoc. If you're not using it, you should use it. Anytime you're doing documentation, this isn't, I don't think it's in the actual like JavaScript spec. It's separate, but it's got very wide adoption. So Sublime Text, Visual Studio, all of the JetBrains tools, all those kind of things support this. And essentially what this is if you ever use Java or C#, there's specific tags that you can use, like this is a constructor. I want to document this particular parameter called title. The type that I'm expecting is a string, and it's the title of a book, that kind of thing. And what this does is this will actually do a couple different things. You can run a tool over this and generate an actual like text document. Nobody ever reads those. But also it can actually, for tooling, it can tie into the IntelliSense. So you can do like your module dot some method, and then it'll read this documentation and then show up underneath the method.
This I do not like.
I don't like it either. It's there.
Is there another slide that you're going to explain why you don't like it?
So I don't
Is this
like.
a do or a don't?
This is a do.
Okay.
Yeah.
Confusing.
Yeah. Okay. So I don't like it, but there's nothing better. So I think I don't like it because it reminds me of my Java days, and I want to cry in a corner. But
well, my big 2 cents on this is that it's either. Here's what always happens. First thing I want to do is like, well, it's already there in the signature,
yeah.
book, title, author. So why not just create a tool that'll just parse JavaScript and then generate all that JSDoc for me?
Yeah.
That's the first thing that happens. And then the second thing that happens is that you get your documentation devolves into those automatically generated HTML or PDFs that nobody reads.
Yeah.
And so it's like I go out to MSDN and it's like nothing but just this boilerplate junk. Whereas compared to, say, not that I'm a big fan of WordPress or PHP, but if you go out to the codex, it's like a human being actually is writing something, trying to explain something to you.
Yep.
And so this is absolutely useless, but because it looks like documentation, even though totally pointless documentation. Thank you. I can see. Oh, there's a parameter called title.
Exactly.
What's its data type? Oh wait.
Yeah.
Oh wait. And author? What's its data type? Oh, it's a string. What is it? A string? Because it really didn't have to be a string, does it? If I don't want it to be a string.
Yeah. I mean, especially if you're using double equal. I mean, it could. Yeah. So, that's probably a bad example. So, parameter ones are pretty useless. Constructor's pretty useless. One of the good ones is example. So you can actually write like example of how to call the method. You can also specify if a particular parameter is optional or not, which is kind of helpful. I
mean, my criticisms towards any language that uses this paradigm. Also, if you're not generating this stuff automatically, then if it gets out of sync and you're using it for IntelliSense, that sounds like a state of sin.
Yeah. So
yeah. I would want my metadata to be generated on the fly.
You should use TypeScript.
C#.
Yes. Yeah. Was it script CS or
Just
script? Oh yeah.
C#++.
Yeah. Yeah. So so basically the difference here is instead of just writing / and then the description, write this way instead of just //. Maybe JSDoc picks up just the double slash now. But there are some things that you can't infer from just the signature, and I would say keep it to that kind of stuff. And like you're saying, don't do specifically.
It's here to stay. I mean, this isn't going to go away.
Yeah. The problem with this, like a lot of times, like what you're saying, is it gets out of sync a lot, and people use that instead of writing just code that you can actually read.
Right.
Yeah.
That's, I think.
Which I run actually read.
Yep.
Yeah. It's not. Again, there's no way out. It's like if you start talking about self-documenting code, then You just don't get. You just get bad. Everything sucks. Everything sucks.
Yeah, everything's broken and nobody cares.
Sucks. But I will say though, a clean API that models some kind of reality and some well-written documentation, it lets prose. You know, like a book.
Yeah,
That's good stuff.
So next thing, performance. So these are kind of some DOM-based kind of things. Things that you should do instead of using jQuery by default. If you don't actually need it, there are a lot of places where you do, and a lot of places where jQuery makes things a whole lot easier, particularly around AJAX calls. If you do vanilla like regular JS and do AJAX call, it's ridiculous verbose and super hard to read. So definitely if you're doing that, just use jQuery. But the actually the document.getElementById is basically the same thing as the jQuery $ hashtag, just the ID name. But it's ridiculous fast. The new jQuery actually uses this under the hood, so it's faster. And then the next thing is, it's kind of an example. React is fast, and we talked about React kind of a little bit in one of my Ember talks and some of the other ones. It's fast because it uses virtual DOM instead of the actual for reals DOM. So it's not actually doing a ton of updates whenever you change things and big redraws. It actually does very, very, very small comparisons and does those individually, or if there's a lot of updates that need to happen, it'll kind of distill it down into just what it needs to update and do it in like a batch instead of just like poo, 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 like a zillion stuff all over the place. And then reuse selector results. So don't like put in a loop and then select the same thing every time and then add something to the list and then reselect it. Just put it in a variable so that you don't have to do that a bunch of times. And so one of the things that actually did for this talk is kind of built an example to kind of show you some of the performance differences. So I've actually got pull up the. So here's the actual page. Basically, what I'm doing is I've got a list, an unordered list, and I'm just adding 10,000 items to it, right? And so I can either do it using regular JavaScript or jQuery or jQuery batch, and I'll show you the difference between all of those. So vanilla JS is just using the getElementById and then creating a new list item and adding it each individual and filling it up and then appending each time. So this is doing one list item each time. So it's doing it individually. The next one, well, got them a little bit out of order, but the next one is just using jQuery. So I'm using the same kind of deal. I'm doing a for each loop, and so I get the list of stuff, and I add a new list item each time, and I append that using jQuery, and then get the results in milliseconds and set that. And then the jQuery batch, I'm actually building out an items list of all the stuff instead of appending each time. I'm getting one big long virtual DOM in air quotes equivalent, and then just injecting the whole thing at the end instead. So I'll show you the performance difference in this. So vanilla JS, just regular JavaScript. This is individual items in a for loop. So it's kind of 19 seconds or 19 milliseconds, 37. So it hovers around there. If I use the jQuery individual ones, which is basically the equivalent, it's a little bit slower, like to the order of 30 times. So it's that's pretty slow. But if I batch jQuery, it gets back down to about 51. So it's about 50% slower, sometimes a little bit more. So the main takeaway from this is if you can keep from it, if you're doing DOM manipulations or very specific things where you need to select an element and then update the DOM, use just regular JavaScript where you can, and do it by IDs if you can, because those are much faster than doing it by class, especially if you have one thing on the page. Get it just by ID instead of by the class. And so another thing that I actually learned from this is that in doing these kind of micro benchmarks, I was trying to figure out some other things that were like really specific that I could say, guys, you should do this every single time forever and ever and ever, and you'll always be faster than not doing it the other way. But that's actually not very good because the JavaScript compilers actually make really crazy, very clever optimizations of code. So much so that a lot of times it'll actually throw away code or remove blocks entirely if it can see that you've got a bunch of items in a for loop and you're using this particular variable in a particular way. It can say, oh, I'll just throw this outside of the loop or whatever, and then it'll say, oh, you're not actually using this, so it'll throw it away. So I found actually a pretty funny little clip that I want to play. This is one of the V8 engineers from Chrome, and he's it's probably about 3 minutes, but he's kind of explaining how JavaScript compilers actually work to optimize your code, and it's pretty interesting. It actually changed the rest of my talk on some of the things that I'm going to go over in a second.
At this moment. Okay. So let's start with this benchmark. So basically that's what GSPerf does with your test case. So there is initialization there, and then it starts the benchmarking loop, and it puts what you put in the test case in the benchmarking loop, and then it returns how much time you spent running this benchmarking loop. It's kind of like that. It's not exactly like that. And the compiler is kind of smart. So of course what it does, it like says, hey, I can just put it there because it was a constant. Like it was a constant there, nothing changed it, I will just put it there. Okay. And then I can evaluate one expression because like application of tilde to the constant, I can fold it. Then I can fold it once again. And wow, we have an assignment of a number to a variable. That's really what we wanted to benchmark. That's, yeah, cool. So this is called constant propagation. It's like majority of compilers do that. So as long as you have, if you're trying to benchmark things applied to constants, basically you're measuring nothing, like assignment of constant to a variable. Here, smart people would say, oh, I can trick the compiler. I will make it not constant anymore. Wrong answer, McFly. No. So the problem is that it's still an invariant in the loop. So it is not a constant, but it doesn't change in the loop. So the compiler, who is smarter than table, will just put it outside of the loop, compute it once outside of the loop, and assign that value to the variable in the loop. Great. We're still measuring nothing. So this is called loop invariant code motion. And also all the JavaScript VMs these days do that. It's essential optimization. Okay. But they can go even further away. They will say, okay, there is an assignment in the loop, but nobody uses the result of this assignment. And nobody uses the result of that assignment. If we assume that, then nobody uses the value that is assigned. And nobody uses the other value either. So I will just throw everything out. There is nothing left there. Only sound of silence, basically. Okay. And if it's a really, really sophisticated compiler, it will say just, okay, why the loop? Why the loop? Nothing left. Okay. You basically have infinitely fast code now. Your tilde operator makes everything infinitely fast. Add more tildes everywhere. Okay. This is called dead code elimination. That means elimination of a code that is dead, which means not used, basically. Okay. Yeah, as I told, most engines won't go as far as eliminating the loop, but like more sophisticated compilers like Java VMs or C++.
Yeah, so basically, there are tons of things that compilers do, and this actually is pretty common in a lot of benchmarks that you'll see online, like the basically all the browser benchmarks. So there's a lot of optimizations that actually happen to where benchmarks aren't really real world examples of what actually happens to your code. So instead of saying like, oh, you should always use this particular function of jQuery over this other one, it's actually going to change pretty often. And there was, I actually took a picture of it, but the operations per second of one jQuery version to another, I think it was from 1.2 to 1.8 or something. It was like a 400,000 ops per second or something like increase or something ridiculous like that. So some of the specifics aren't that really important, but I want to try to go over the things that are a little bit more timeless that you can use to help make sure that your code is performant.
Well, now, like in C, there's compiler switches. GCC will let you just specify the level of optimization. Is there any way to turn any kind of that thing off in your, like, is there directives or anything that you can use in JavaScript? I'm sure it's engine specific, but
yeah, it's engine specific. So you can use the use strict for JavaScript, so that makes it be more strict, right? So it helps you not to write things that are in general inefficient or bad or are kind of iffy. So that can help increase performance a little bit, and it can also, if you use tools like JSLint, which is basically like, it's not really a compiler, but it's kind of like static analysis almost, where it'll go kind of crawl your code and say, oh, hey, you're using double equals here. You should really think about using a triple equals because that's a little bit better. And it'll do the same thing like with variables. Like he was saying, they had that chunk of code that was like 7 or 8 lines, and running in the browser, the compiler is basically like, this is nothing, so I'm just going to not use this code. Well, that code is still going across the wire. It's still taking up space. It's still taking time to process and boot up. The compiler's still having to analyze the code and figure out what it needs to throw away. So if you can use JSLint or look at your code and say, oh, I'm not actually using this variable anymore, I could just remove it. That kind of stuff actually goes much farther than trying to micro-optimize your stuff that may or may not even be real, in the future.
did you run across anything where you could disable the optimizations?
No.
Short of maybe doing a
There may be something in
custom
that.
build of Spider Monkey or something. Did you run across anything where it was doing optimizations? What's the phrase called? I guess it's called dynamic analysis, as opposed to static analysis, where it's all those optimizations that you were describing were done at parse time.
Right.
But since JavaScript is a runtime engine, there would be an opportunity to do optimizations based on current state of the heap.
Yeah.
Object graphs, things like that.
Yeah. I'm very sure that happens. But I don't know of any specifics without cracking open code.
Yeah, I don't know. I was just curious if you came across it.
Yeah. I'm very sure that happens because it actually, the longer that you run it or the more times that you run some of these benchmarks, it'll like drastically drop in speed once the compiler kind of figures out, like you were saying, like if something's the same every time, ends up that way, then it can make those kinds of optimizations. And that kind of stuff changes so quick that instead of trying, and like you were saying, like benchmarks are really, really hard to write, and sometimes they're even meaningless. It's better if you're writing something and you're using something that's slow, to submit like a ticket, actually a bug in the bug tracker for whatever browser vendor that is or a library, whether it's jQuery or something else. Just submit a ticket and say, hey, this particular thing is slow, and you're much more apt to see that, in the next version. So making sure that you stay on the latest version of libraries is definitely really, really important. and removing unused code like I was saying. Another step, of course, is using minifiers and bundlers, which will minify all your code. So that's like if you have a variable name called my super duper awesome variable, it's a bunch of characters. If you run it through a minifier, it'll actually reduce that down into something like X or something really, really short. So when you send it over the wire, there's a lot less data to actually go. And so that can generally speed up a lot, especially if you're bundling something like jQuery. If you're using jQuery debug version locally, and then you ship that off to production, it is much, much bigger than the minified version. So that can increase performance a ton. Also, caching. If you're not doing caching, you're using CDNs and things like that, you should definitely do caching. Just simply caching something that like an image or CSS that you're not otherwise can like way outperform something like you trying to go through and analyze like your little tiny for each loop that you're trying to update something. Upgrade your libraries. Yeah.
It's not so little.
Yeah, maybe it's a big one. I don't know. Maybe it's a nested loop. So yeah, upgrade your libraries. Like I was saying before, like as you go up in versions of jQuery, it gets ridiculously faster, much faster. Especially if you're going from, if you don't need to support older browsers like IE6 and 7 anymore, which hopefully you don't have to. Then you can upgrade to jQuery 2, which is where they dropped a ton of the older browser stuff, and that dropped the payload a ton, and it's also much faster. It uses the document.getElementById by ID under the hood, so it's a whole lot faster. So definitely upgrade your libraries. There's a ton of free performance stuff there, and that's something that a lot of people overlook because they're like, oh, it's probably going to break. Well, if you're using something like jQuery, they do deprecations, so they should warn you in the console if you're actually using something that's deprecated. So it'll tell you like, hey, you shouldn't use this. You should use this other thing instead, and it like literally tells you what you need to change to upgrade. And jQuery is so widely used that that they have a ton of pressure to not break their API. So 9 times out of 10, upgrading jQuery is not going to explode your site. Yeah. So you can get a lot of free performance just by upgrading. And the last performance thing is learn to fish. So these are some things that you should probably be familiar with already, at least the F12 tools. So by F12 tools, this is my last slide anyway. By F12 tools, I mean you hit F12 and the developer tools come up, right? So if you so the developer tools are where you should kind of invest your time instead of trying to figure out exactly which things that you should use over something else. Because with most frameworks, like if you're using ASP.NET or Rails or something else, there's a lot of things built in like bundlers and minifiers and things like that that'll make your site pretty fast already. Servers are getting fast enough now to where we've got a lot of space to move. So you're probably not going to have a ton of performance issues, but if you do, you definitely need to know how to debug your site because it's probably going to be something different every time. So does everybody know how to do this? It's totally okay if you don't, because I want to show it anyway. I don't know why I asked that. So let's. So if you don't know how to use DevTools, this is a really good site to actually use. It's called webpagetest.org. So basically, what you do. So let's say anybody got a website that they want to test out? Reddit. Runhaze.net. Yeah, that one's probably pretty bad. Yeah. Yeah, don't spend a lot of time. Yeah. Yeah, so this is there's a bunch of different ones out there, but if you don't this is kind of the easiest to use. It'll point you to some low-hanging fruit as far as performance goes. So I'll let that run for a second, and I'll pull up runhe's.net.
Do you still have to use Fiddler? Doesn't Internet Explorer have something like that built in now?
Yeah, so Internet Explorer and Chrome, they all have the network tab, which is pretty similar, but it's really just related to like the actual network that's related to your web app. So yeah, I mean, you can with Fiddler, some of the things that you can do is like tinker with different things. I think you may be able to throttle stuff too. I think. So you can kind of test out like errors that may happen if something times out under the hood and how you handle it.
I haven't opened Internet Explorer in a couple of years.
Yeah. Their dev tools are actually pretty good now.
Yeah.
Yeah. They finally started kind of putting some effort into it. Whoa. Yeah. So Chrome, this will be good for like Mac people, Windows people. Everybody's got Chrome on their machine. So let me actually load this up again. So the network tab is really good. I'm going to pause it right now. So that captured the first like 6 seconds roughly. So the network tab shows you a lot of like little lines here, and all of these lines are the browser doing something. You'll generally see this first line all by itself, and this is the initial request for your web page, right? So this is the web page saying, "Hey, I need runhays.com," and then it's saying, "Okay, let me get it all together," and then it throws the initial HTML document to you, right? And so this line here, you can kind of isolate and say, "Okay, it took what, like 642 milliseconds to get that initial thing." So if this takes a really long time, that's your hosting or like your ASP.NET backend or your database, your initial database hit. So if there's some performance issues here, you can say, "Hey, I need to," like if this is 3-4 seconds, you should probably take a look at that. And then you can
But if it's dynamic, it would typically be the longest request because everything else is static.
Yeah. So if you can get this down, this is super helpful because you'll see, like, as soon as that gets finished, there's this super massive chunk of everything else. So your browser doesn't know if your app's going to be using jQuery or if it's going to be an Ember or Angular app. It doesn't know if it's going to use some custom library or something else until it gets this first one back. It can do a lot of cool stuff here because it can, in parallel, go fetch everything else. But it's not even going to start until this first one gets done. So this is pretty important for like single-page apps because if your initial server load is pretty slow, then it's not even going to start like downloading your big JavaScript app until that gets back. So that you can isolate that there. And then each of these individual lines you can see on the network tab how long it actually took. So you can say, these took this long. Here's one that took up 400 seconds. All these kinds of things. So here's some ads coming in later, that kind of thing. So if something's taking a really long time, you can kind of isolate it. The other cool thing about the dev tools is you can see the status code too. So of course, if it's like an AJAX call or if it's just pulling down particular JavaScript version or something, you can actually click on any of these things. And since these are all just regular network requests, right? They're just regular old HTTP stuff. You can actually see all the headers and actually preview the contents. So you can see the actual JavaScript file that came across. This is actually really helpful if you're debugging like ASP.NET apps or I'm sure other ones too. If you get like a 500 error or like something happened on the server and it blows up, you can actually go to the actual request that blew up, click on preview, and it'll show you the contents, like the actual JSON contents, if it's successful, or if it's not, it may have like an error message, like a JSON object with the error message in it. So that's a really good way of tracking down errors. And then if you want to get really crazy, there's the timeline. And so this is actually this is good for like single page apps and stuff like this, but this will track like memory usage and CPU time and like all the nuts and bolts of things. So I'm gonna stop recording, and so it'll track all of the actual JavaScript that was running on the page since it loaded up. So you can see there's a timer that's going off. So this will include also any kind of like LastPass injects some stuff to be able to insert passwords into the page. So it includes all of that. So another tip is if you're trying to nail down performance, use it in a browser with no plugins, or pop open like an incognito mode. So that way it'll remove all the plugins, so all of that other stuff won't be in it. Because otherwise you might see like, oh man, my page took like 6 seconds to become like for reals active or whatever. But it could just be like you've got 12 plugins that are just firing up and injecting stuff in the page. Let's see here. All these are pretty fast. So what I'm looking for is a bigger jump. Yeah, so here's some painting. So it actually tracks every single thing on the page, so you can see like when this block of stuff got painted. Here's when this image came in for Google, I guess. So you can see the actual time. And so what that lets you do is you can see where all the stuff is actually happening. So if you see a big chunk that's taking a whole lot of time, you can narrow it down to there, and instead of trying to optimize things that don't necessarily matter, you can focus in on specific things that do. Yeah, so you can track memory and all that kind of stuff. Lots of really cool tools in there. Yeah, if you don't know, I mean, the dev tool, all the dev tools have really good debuggers in them, so you can actually set, if you can find your specific JavaScript on your page. So I'm going to go, here's like Facebook's, whichever one it downloads. Some JavaScript from, or whatever this is. Oh, they just inject some stuff. Nice. So here's some JavaScript or whatever, and you can put breakpoints just like you would in Visual Studio or IntelliJ or something else. And as it's running, if it runs over this, it'll pause, and you can step over it and hover over values and see what the variable values are. One of the good things that I don't think the Chrome tools have. Preprint. There we go. Hey, yeah, preprint's good. The IE Dev tools have a Just My Code button where you can say, I want to debug just my code. So if there's an exception that happens somewhere on your page that's unhandled or something, normally it'll break on anything. So even if there's an internal jQuery something other that blows up and it catches itself and keeps going, it'll pause on everyone, and it gets kind of annoying. You can set that Just My Code flag, and it'll actually bypass jQuery and any other things, and it'll just focus on your code. So that's pretty nice if you're, especially if you're doing like a single page app. Yeah, so there's a lot of other things too, not necessarily related to JavaScript, but on the resources tab, there's some tools for IndexedDB and WebSQL, and you can view all the cookies for the page, that kind of thing, session storage, local storage, app cache, all that kind of stuff. And then, of course, if you're building a single page app, look in the Chrome store, because there's a lot of plugins that are specific for different apps. So like Angular's got one and Ember's got one, and it just adds another tab for whatever specific framework that you've got. So yeah, that's pretty much it.
You didn't have any more slides?
No. Yeah. Oh yeah. So back to the performance audit thing. Yeah. So if you don't want to spend time with the dev tools, one of the things that this actually does is it's got a good kind of like a low-hanging fruit tab. It'll show you all the different things that you can do for your app that you may not necessarily be doing. So like time to first byte is that initial server hit, saying like the initial page hit needs to be really quick, so we can go ahead and start downloading all of the JavaScript and other stuff, right? So compress the transfer, so you need to gzip everything, cache it, all the static content, use a CDN. My images are not compressed, so they're massively big. So I could probably fix that and compress my images first. So this is a really good kind of like, if your website's slow in general, these are pretty easy things to fix, and it can give you a good, quick overview of stuff that you need to do. Yeah, content breakdown, all that kind of stuff. A lot of JavaScript. And it even breaks it down a little bit further into the specific things, so it'll show you the slow stuff. Yep. So that's pretty much it. Some crazy stuff in JavaScript that you need to watch out for. Performance. Pretty much the main things to focus on are the network, because JavaScript compilers and those kind of things, they change so fast that it's really no use of trying to micro-optimize unless you're an actual library vendor and you're doing like low-level stuff. It's generally better to just remember these kind of overarching things. Just make sure that you don't send stuff over the wire that you don't need. Use your dev tools properly whenever you see a slow site, that kind of thing. So, yep. That is it. Thanks.